Okay, so welcome back to this series of rendering and render passive videos that I'm creating for RenderMan. The first video was on render settings and doing a basic render, understanding a little bit of image tool just to get you started and for you to just kind of navigate and understand what's going on. Second video, we talked about adding render passes to our outputs or to our render that we can use later on in compositing to tweak our image and make our image better or correct any problems we might run into. Um, and also in that video series, we went over or that second video, the lighting channels, which is our render passes that are lighting and material focused or related, right? So in here we have our RenderMan tab, and this is under the render settings. So our RenderMan tab, we went to AOVs, arbitrary output variables, which is where our render passes are located. And so we were looking at the lighting ones, right? And let's just quickly, briefly recap those, right? So here's image tool, here's my render. This is my display, which is on the right-hand side, which is our output or our render. And packed inside that is all of our render passes or our channels, right? I'm just gonna open that up and I'm gonna take a look at a few of these. So we looked at, these were all the lighting and material interactions passes. So we went to direct diffuse, which is the diffuse shading component for our materials that are influenced by the direct lighting from our light sources, right? So this is like the lighting interactions that come straight from our lights, right? Indirect diffuse is going to be that shading component, diffuse shading component, but the light is coming from other objects and not directly from our light sources. So indirect, which means that the light's not coming direct, it's bouncing off other objects. Specular is going to be the specular shading component in the Pixar surface, and that's going to be our more reflective, sharper reflections on our objects. So the specular reflections. So that's kind of like that shininess. If you're using metal or if your object has like a glossier look to it, that's going to be that reflective component. And again, direct specular means it's coming directly from the light source. Indirect specular is going to be that same shading component, but all the light's bouncing off of other objects. So it's coming indirectly to my objects. Subsurface is going to be the lighting interaction or material interaction of light um, penetrating and going beneath the surface of our object, bouncing around, picking up color, and coming back out. So very common for skin, certain minerals and materials like jade or amber, not amber, marble, and then things like fruit and organic material like that, that you can see that light penetrating that surface. Okay. Transmissive is going to be light transmission through glass-like objects, so light traveling through the object from one side to the other. And so we use the transmissive glass globe for that render pass, right? And then we also looked at emissive, which is going to be our glow attributes color. So if any of our objects have a glow setting to them, this will be that color of that glow coming from that object. And then also our albedo, which is going to be the color set in our diffuse channel on our Pixar surface, right? So if I select this ring, it's going to be that color right there under the diffuse, right? And so it's going to be just literally the surface color in the diffuse channel without any lighting. Okay. So today we're going to, or with this video, we're going to be looking at the standard passes, which are going to not necessarily be lighting or material related. Some of them are, but a lot of them are, it's a lot of extra data that's used for more compositing, but also used for diagnosing our render images and understanding what's going on in our scene, right? So to look at them and get a better sense of those render passes, I recommend checking out the arbitrary output or AOV RenderMan document page. And so that's going to have visual representations as well as a little bit of extra information on what these do or what they're trying to show. Okay. So CI is going to be just actually just like our beauty render. So it's going to have all the lighting calculations baked into it, into that pass. Alpha is going to be essentially a mask or a representation of where our 3D scene or our 3D objects are and where we have nothing in our 3D scene. So you can see in this render, we have a floor in this teapot, and in the background, there's not anything 3D wise in that scene. So that's just a blank pixels. And so those come through as black or 0. So that's useful for essentially masking out that background. So we can drop in like a background painting or something like that. We have things like ID, which is going to assign a color to unique objects in your scene. We also have CPU time and sample count, which are actually found underneath the diagnostic channel. So we come over to standard. This is where we've been seeing CI, the alpha channel. Where is that at? Alpha, and some of the other ones. And then that we're about to look at, and then diagnostic is down here. So CPU time and sample count, they're for diagnostic, which means they're diagnosing, we're using them to diagnose our render results. So CPU time and sample count are just going to calculate the different parts of our image that are harder to calculate for RenderMan and for the computer. So anywhere that requires more advanced or a greater number of light interactions or bounce interactions to properly calculate and estimate it, those areas are going to take more time for the renderer. It's going to take more samples, and it's going to visually be representing these images as like a hot spot, showing us, oh yeah, this area, these shadow areas are going to be harder for the renderer to calculate because it's primarily lit through bounce lighting, which is not coming directly from the light sources. Curvature map, which is, if you're familiar with Substance Painter, you're probably familiar with what a curvature map looks like, but it's just that rate of change of how the surface is turning a corner or turning an angle or direction. So see flat surfaces, like the tops of these little steps are black, and then the corners and the edges are all white. Okay. We also have a normal pass, right, which is showing the orientation of parts of our polygons, or parts of our polygon objects, and their orientation relative to the world. So are they pointing up and looking up at the sky, or are they looking down? So that's the green channel, or the y-axis. And are they facing to the left or right, which is the red axis, right? Or the red color, which is our x-axis. So more, you see it's red over here, it's pointing over here, and over here it's black, so it's pointing in this direction. Okay. DPD time is going to be a visual representation of our objects or parts of our image and which direction they're moving in our scene and how fast they're moving, right? And then Z depth is going to be our camera depth. So it's essentially the distance from our camera or our point of view to the object. So things that are closer are one color, and things that are getting further away are a different color. So you can see here the teapot is closer to the camera, and then that back part of the plane is further away from the camera. Okay. So I recommend checking out this if you want to know a little bit more about specific passes, but we're going to be taking a look at 3 in particular. So the 3 I want to look at are the alpha, the Z depth, which we'll come back to in a second with why this looks like it's just white, and then the DPD time, which is going to be our motion vector, a 2D motion vector render pass. Okay, and I'll talk about why we want all 3 of those. So let's start with alpha. So first I'm going to add all 3 of these actually. So I'm going to start with my alpha, my Z depth, and my DPD time. Okay, and I'm going to go ahead and add those to my display. So I'm just going to select them, select those channels, select my display or my render output, and then click this button right here to add them there. And I have them here, alpha, Z depth, and DPD time. Okay, let's start with alpha. All right, and I already have these rendered out. So my alpha looks like this, right? So this is just 0 to 1. It's either 0 or 1. So it's either there's nothing, there's an object, 3D object in this part of the image, or there's not a 3D object in this part of the image. So if it's black, it means it's just background, there's nothing in the scene. And then if it's white, that means we have something in the scene. So I pulled this up in Nuke, right? So over here, we have our image here. And so compositing, in general, it's nice to have, well, it's almost probably at a certain point necessary to have an understanding of digital images and how digital images are working and how you manipulate them. You don't have to have like a super in-depth knowledge of digital images under the hood and how they're working, but it helps to understand the color channels and what those values mean when we're working with them, especially if you want to start blending things together using the merge node and blending modes. Merge node blending nodes. Merge node blending modes. So if you've ever used Photoshop and you've had layers that have interacted with each other, like you've set one layer to multiply on top of another layer, those pixels are doing some kind of mathematical, interaction or equation on top of each other. Like you're taking one image and you're adding it to another image instead of just slapping them on top of each other. Okay. But anyways, so I'm coming in here because I want to show some of these values for some of these images. So in Nuke, if you hover over your viewport, it's going to give you, based on where your mouse is, a readout of the red, green, and blue values for that pixel you're highlighting over. So let's take a look at it actually for the beauty pass. So you can see when I zoom in, right, just as hopefully you know by now, that all of our images are made up of pixels, right? So solid picture units that are essentially, when you get down to a certain level or a certain resolution, they're just solid blocks of color. So it's just each part of my image is represented by a mixture of these values of red, green, and blue, right? So each of these colors on my, so for instance, if I come out to here, if I highlight over one of these pixels on my nose, like for instance on the nose, you can see it's like an orangey color. And so you can see that red value is going to be higher than the blue value. So if I hover over that nose, the red is 0.75, while the blue is 0.34, right? So the red is has a higher contribution or higher presence, so shows up as more red. Right? If I hover over this blue over here, right, the blue is 1.59 or 1.6, and then the red is close to 0, right? So it's more blue. It's handy to note that typically in the normal color range, Nuke is going to treat the maximum of your values or your channels as 1, and then the minimum as 0. So black is going to be 0 in all 3 channels, and white is going to be 1 in all 3 channels at the same time. Okay. If you have data coming in with different image formats, sometimes you might have pixels or colors or values that are beyond 1 and 0, right? So you can have some negative values, and you can also have values that go higher than 1. So you can see in here, I was highlighting over this, so highlight over this part of the chest, right? You can see that red is going up higher than 1. It's 3.6 right now. And if I come over to this chest piece, wow, that goes up to 326, right? So some information that's coming in from RenderMan isn't clamped, right? So it's kind of like raw data. So some of these intensity values from my 3D scene, they have greater energy values than just our 0 to 1 that we're used to looking at with our pictures, right? The image or the view port is capping it off. So if anything goes over then that number, like so if these values are higher than 1 in all 3 channels, then it just turns out to look like it's white. It just becomes white. And then the 4th channel is our alpha, or our transparency, whether our pixel is solid, like as in it exists, or it's not existing, like we can see through it. So if we have a layer underneath it, we can see through that layer, right? So the alpha channel, what's handy about that is we have this really easy, simple mask that goes from 0 to 1, right? So 1 is, all 4 channels are going to be 1, where it's white, or where we have our 3D objects, and where there's no 3D objects, it's going to be black. So what's cool about that is I can take 2 images. So I have our beauty image here, and I have this background image. I just grabbed around a background image that's the same resolution. And I'm going to merge them together, right? So by default, if I just merge them together, so let's just do a normal merge, right? And I'm just going to set this to a top. Okay. And I look at this, right? What it's going to do is it's just going to write one of these images on top instead of the other. And if I hover over the operations, it's going to tell me essentially how it's calculating the combination of my 2 images combining together, right? And so at top, it's going to be using an alpha, right, image. or a mask to essentially determine whether A is being shown or B is being shown. Right now, I don't have an alpha controlling it. So right now, just B is being completely overriding A. And if I swap those, oops, if I swap those and put that over here, now B is being overriding A. So it's just all the pixels are just taking over and replacing the pixels from this image, right? But oops, let me go undo that. Let me get rid of this one. But what I can do is I can use this mask to control whether image A or image B are showing, right? So normally image B is going to be overriding and showing everywhere, but I'm using this mask right here to say where image A is going to be showing. So right where it's white, it's going to say, okay, show image A instead of image B. So it's essentially wherever this is white, it's going to cancel out this background image right here. And just in this configuration, that's not always true. Depends on how you set this up. But you can see here, because I'm using this mask image right here, that mask image is telling me where that background is versus where my 3D objects are going to be in this image. Right? So this is a really, really basic mask for just kind of getting that background matte painting that I might need. So later on, if you, in the later video, we'll go more in depth into creating more refined masks using things like Matte ID or CryptoMatte, which will essentially let us create masks for individual objects instead of all three of our objects in one image like this. But that's the alpha channel. Okay. So let's take a look at the next channel. So the next one is going to be the Z-depth pass. So the Z-depth pass looks kind of weird when you first render it out in RenderMan. And this is kind of why I wanted to take a look at those colors inside of Nuke, is because by default, you might not actually feel like this image is working, right? If you've seen what typically what a Z-depth pass like looks like when people visualize it to people or to you on the internet, you'll see that image that we saw on the RenderMan documentation page, right? Which is, you know, a color representation of how far away our objects are from the camera. So when they're closer, they get closer to black, and when they're further away, they get, oops, I'm sorry. When they get further away, it gets closer to white, right? So that's just representing visually how close parts of my scene are to the camera. And so let's go ahead and bring that into RenderMan and understand, or Nuke, and understand what the heck is going on here, right? So right here I have my my image, right? So this is my Z-depth pass. And just like what we were looking at before, where we were taking a look at our render pass, our view pass, and we are seeing those values changing right here to kind of understand the values in our image. You'll notice when I look at this, you would expect this all to be just like this, oops, sorry, just like this alpha image where it's white, all those values are just one. But when you look at this, these values are actually changing, right? Even though this is just flat white, and you can't see anything, they're changing. And that's because this data that's coming in from RenderMan, they're using values that are greater than one, right? So greater than white. And the reason why that is because it's just measuring a distance from the camera to that point, right? So these values represent a distance from the camera. So naturally, those aren't going to be just capped between 0 to 1, right? We can adjust it to be between 0 and 1 so we can visually look at it. But in most cases, you're going to just be using this as a measurement from your camera to your object, right? But if we wanted to take a look at it, what we can do is we can add a color correct node, right? And we can actually adjust the values of our image. So by default, just set, if it's set to 1, we can actually darken and darken, and essentially we're reducing our value range. So we're bringing those values closer and closer to 0, right? And then now they're less than 1, right? Because I'm using this color correct. I'm not going to be using this for anything, right? I don't need to color correct the Z-depth pass. I'm just doing this so we can visually see what's happening. And so you can see here my 3D scene is being represented from black to white based on how far away objects are. So you can see this sphere in the front is 0.47, right? So it's closer to black. And this object right here, that's 0.047. And then this object over here is 0.25, which is closer to white. So that's for, so it's, yeah, so we're just bringing it within that range, right? So that value is higher, which means that distance from the camera is higher. So it's further away from you. So why might we want to use something like this? The primary reason why we might want to use it is for depth of field, right? So in case you're not aware, hopefully you are, you've probably seen it before in pictures, but depth of field is just the essentially the visual effect from cameras, and our eyes do this as well, of this plane of focus, and this depth of field is essentially what part around what we're focusing on is visually in focus, right? So as something is, when you have a greater depth of field, or the further away things get away from what you're focusing on with a camera or with your eyes, as you get further away, those other objects that are farther away start to become blurry, right? So in this case, we're focusing on this camera, and that's sitting on the grass, and everything that's around the camera is in focus. But as objects get further away from that point of focus in the scene, or in our environment, or in the real world, they start to go out of focus, right? And a lot of this is based on our camera settings, right? So sometimes you'll see images where the entire image is completely in focus. And then sometimes you'll get something like this where you focus on something really close up nearby and the background's just completely obliterated, right? So this is depth of field, right? And so this is kind of a nice effect because it's is something that is found in the real world, right? Through cameras and through our eyes. So it's like how we see the world around us. And so by default, when you render out RenderMan, these settings are, or our images are completely in focus. There's nothing out of focus, like in a real camera, right? So what I can do is I can use that depth of field. I can do it in Maya and in RenderMan in my camera settings, so I can actually do depth of field in the render. But personally, I like to do depth of field in compositing because it gives me more control over the depth of the field without having to re-render, right? And so I'm using, again, you don't have to worry about everything with Nuke, but here, what I'm using is a Z defocus node, and what it's going to do is it's going to use that this image right here, this depth pass, to essentially determine where different parts of my scene are in focus or out of focus. So I can turn that on, and you'll see with this node, and I looked at this last time, I can move that point of focus, or that plane of focus, so where I'm focusing at, around my scene, and then the things that are not in that same plane, so that same distance away from the camera, those things go out of focus, so they start to blur, right? So that's the primary use for Z-depth pass, and that's about the basics of it. I like to use Z defocus and compositing with a render pass because it lets me animate and move around and tweak these settings perfectly without having to render a bunch of times, right, to get it perfected. And especially if you have characters moving through your scene, and you have depth of field on in RenderMan, or in Maya, if you go into your camera and turn on depth of field, the problem is you're going to, if this is baked in the camera, it's not a render pass, then if, for instance, your character moves from close to the camera and further away from the camera, your character might actually go out of focus when you don't want them to. So sometimes until you do your final render of your entire animation, you might not notice a potential issue you have with your depth of field. Okay. So personally, I like to use this Z depth pass to do the depth of field inside of Nuke. Okay. You can also use depth of fields to create a essentially atmospheric perspective or fog. So if something's further away from the camera or further in your scene, you can change its color or make it look different. So one example would be atmospheric perspective, which is the visual effect of essentially particles in the atmosphere coming between you and that object you're looking at, right? So these objects, as they get further away from me, there's more atmosphere. So there's more particles in the air between me and that object, right? And so those particles in the air are bending and reflecting and changing the color of the light that's bouncing off of that mountain in the background and hitting my eye. So that's why when we look up close, the objects that are near us look like their true color, right? They look like a normal color. And as things get further and further away, they start to pick up this color of the atmosphere or the sky, right? Let's see, what's another example? So yeah, you can see here, up close, right, looks normal. And as things get further and further and more distant, the more atmosphere there exists between you and that object. So it starts to change the contrast and the color of that object, visual representation. So what's really cool is with the Z-depth pass, I can actually, I can calculate how far away these things are, and because I have that image, and I can use that to just do a simple merge, right? So I have my image, a simple compositing of that atmosphere. And then I have a blue, actually this one's just black. You can set it to a color. Let's just set it to a color just so we can visually see it. Just set it to a bluish color that we might see in the sky, right? So I have this image right here. I have my Z-depth pass that I'm color correcting for in this case so that I can get these values and use them as a mask. And here you can see I'm actually using that color correct node to, or that Z-depth node to either turn on the blue square or hide the blue square and only show my rendered image, right? So if I come here and I change that contrast on that image, right, you'll see that I can like essentially change that effect of, things that are further away, like kind of fading out and having that appearance of atmosphere. Doesn't work at this scale because these objects are very local in terms of size, right? They're like more our size and more our distance. So it doesn't really make sense unless you have like smoke or fog or something like that in your scene where it's something that's literally like obscuring. But you could use this pass as that kind of control over things that are further away or closer to the camera. So that's another, more of like a fringe or edge use, but it exists. Okay, so that is Z-depth, right? So that's just that Z pass that we added here. Okay, the last one we're going to be looking at is DPD time. So DPD time is that visual representation of how fast parts of our scene are moving in our animation and in which directions they're going. Okay, this is called a vector motion blur pass or 2D vector motion blur pass. So it's just a flat image that is going to be telling through colors or through vectors which direction and how fast those parts of my scene are going, right? So just like with the normals pass, right? Those colors represent that 3D space, right? So red is going to be the x-axis relative to my camera, I'm pretty sure, going left or right. So if it's red, it means that object's either that part of that image is moving to the left or moving to the right. And then if it's green, it's moving up or down. And then blue is going to be moving towards the camera or away from the camera. Okay. So you can see just from looking at this image, I can know that on the next frame of my animation, that this part of the head is going to be moving to the left. And then this part of the head is going to be moving forward to the camera. This part of the arm, I can tell, or most of the arm is just going to be moving up in the y-axis, right? So y-axis or up or down is green, x-axis or left and right is red, and z-axis, forward or back, is blue, right? And everything that's not moving my scene doesn't have a color because they're not moving, okay? So in order to render this out in RenderMan, we have to add our DPD time. It's the 2D vector motion blur pass is called DPD time. So we have to add that as normal. But we also have to go into features to turn on calculating motion blur. Okay. So we don't want to use camera blur because just like using depth of field in the camera, so letting it render out and bake into our image, by baking in the camera or turning on camera blur, what's going to happen is the rendered image is going to have motion blur already packed into it. Like the actual beauty pass will have motion blur in it. And personally, I don't really like that because I like to have that control. And if my if my render is blurry, right, and if I want to like try to mask out something, my mask, like if I have a mask for my character, it might not work because this rendered out image, if this is what my image is rendered out as, it's actually blending multiple objects together. Like the pixels are actually blending in that motion blur, it's blurring them together. So they're actually merging the foreground and background pixel or colors of those objects together, right? So it's baking into the image. In this case, this isn't the case because I'm actually using vector motion blur. So I'm doing it inside Nuke, but pretend that this was what came out of RenderMan as my beauty pass, right? So personally, I don't really like that because I like to have that control. and I like to be able to change these settings inside of Nuke, right? Just like we were looking at last time, right? I like to be able to turn on and off. And if if I rendered out my entire animation and I noticed the whole thing was totally like in a certain part of my animation, like an object moves a little quickly, and then all of a sudden we see this huge blur and it was really distracting, I might not catch that until I'm fully done rendering. Something to keep in mind is that, as always, depth of field and motion blur are always more accurate if you actually do it in RenderMan in camera. So these are kind of, we can get pretty accurate results with these render passes and with these nodes in Nuke, right? To the point that most of the time you won't notice. But if you go to a certain to any studios, there's, depending on what studio you're working for, there might be a good chance that they want you to do it in the camera because the render can calculate more accurately than Nuke can, right? And the reason why is because at render time, it has all this extra data in my 3D scene, right? It has all of these relationships between these 3D objects. And so it can calculate these things more accurately. But when we come to Nuke, we're just working with flat images, right? Flat images that have a lot of data in them, right? So they're giving us a lot of extra cool data to work with, but they're still flat images. So they're still pixels, and they're not 3D objects to Nuke. So as always, motion blur and camera blurring inside of the renderer or inside of camera are going to be more accurate than trying to do this in Nuke. But that being said, this gives it a lot more flexibility and control, especially if you screw something up or you render out your image and there's your final image and there's something off, right? Whether something's out of focus or something's blurring when you don't want it to. And so you wouldn't be able to fix that without having to re-render your whole animation. So you have to balance that kind of, what's more valuable. For your projects, that accuracy of whether you do it in camera or in Nuke, you don't really have to worry about that at this level or this quality of rendering. So it's probably almost always going to be better for your school projects just to try to go ahead and do it with the render passes, because it's just going to give you more flexibility later on. Okay. So let's go back to here. Okay. So in order to turn on the motion blur, right? So we have to add the DBD time pass. And then also, we don't want camera blur on. Do not turn this on because it's going to bake it into the renders. And then this is by default going to be off. So in order to get that image to show up with color in it, you need to turn on 2D motion vectors, right? And so that's going to calculate essentially where our parts of our objects in 3D space are moving relative to the camera for our image. Okay? So once we turn that on, then our DBD time render should show up like this. And then inside of Nuke, I can just use something like a vector blur node, and it will use that pass to simulate motion blur. Right. And because my objects are moving so slow, there's just naturally not a lot of motion blur, so I had to crank up this value. But you can see here, it's as if my objects are moving super fast. And so it's using that pass to push these pixels and blur them together. Okay. So that's the motion vector blur. So that's pretty much all the standard ones I wanted to cover. The next video will cover lighting groups, and so how you can separate your renders or your lights into separate render passes. So you can turn on and off lights like I was showing in the previous video, where we are just taking like the key light and we were just turning it off and on in our render, right? So without having to render it off, right? So that's the standard passes, and the next ones would be light groups, then probably masks, and then Nuke. Okay, so that's it for this video.